So in this video, we're going to continue talking about the concept of flow we introduced in the previous video and apply it to a practice question. Now, this is saying that in a directed graph on the right, the vertices A, B, C, D, and E represent towns, and the edges of the graph represent roads, and the weights of these edges are the maximum number of cars that can travel on the road each hour. The roads only allow one-way travel. So this is an example of a weighted network diagram, and we have these arrows to show the direction through here. Now, we're using the same kind of ideas of flow to interpret a sort of trickier question like this. Now, part A is saying find the maximum flow from A to E through town C. So one thing is we have to pass through town C here. So there's basically only one route we can take. I mean, we can go down to here, but that doesn't pass through C. That doesn't work. So we have to look at this particular route from here to here. So this is going to be the path A, B, C, E. Now, it's saying find the maximum traffic flow. Now, you can see here right at the start, we can only fit 300 cars per hour. Next one, 600. Next one, 800. If we talk about the idea that we talked about before, then you'll see that we're limited in this network by the smallest weighted edge. So the 300 cars, they're going to be our limiting road, our rate limiting road. So here, the maximum traffic flow at any period of time from A to E, passing through town C, is going to be 300 cars per hour. You can just write 300, but I'm just specifically talking about the context of this question. Because if you think about it, there's only 300 cars passing through here. So these ones, as they pile up, we're going to get 300 that go through here, and then 300 here. That's the maximum flow of cars in this network system, because we're limited by the smallest individual edge of this network. Now, the next part is telling us to find the maximum traffic flow from A to E overall. So this is where we get something slightly different, because when it's saying A to E overall, it means we can either take this route that we talked about up the top, or we can take this one down the bottom. It's just saying A to E in general. So there's two different kind of paths we can take. Now, we said that for this top one, the maximum flow is 300 cars per hour. But we also have another possible route we can take, right? So we're not just limited to this green one that I've highlighted. We can also take the yellow route, because it's specifying we just want to get from A to E. So we have to consider these edges on the bottom and say, what is the maximum flow through this path A, D, and E? Now, as we've done before, we are going to say that we are limited by the smallest weighted edge. So the maximum flow in this section, ADE, is going to be 150 cars per hour. This is our maximum flow on this path down the bottom. Now, it's saying just the general maximum flow from A to E overall. So we take these two, we can get 300 cars per hour on the green route, we can get 150 cars per hour on the yellow route. So what we're going to say for part B is we have 300 plus 150, which gives you, 450 cars per hour. This is how much can flow through the entire system. But we're still really just taking in the ideas that we discussed before. Now we just have a different route we can take, because the question hasn't specified where we have to go. Now, the last part is saying that a new road is being built to allow traffic from town D to town C. The road can carry 500 cars per hour. So the first part is just saying to add this road to your directed graph. So all we're going to do is it's from D to C. So we're going to draw this here. This is our new road, and it can fit 500 cars. So that's our first part. Now it's saying find the maximum traffic flow from A to E overall after this road is built. Now, Just looking at this, it's not immediately obvious the impact this is going to have. But once we go through our network diagram, you're going to see basically where just adding one road can actually be quite powerful in increasing the flow of cars. Now, once again, we're looking at the maximum traffic flow from A to E. So we're going to consider all our different routes once again. We can have this first one here. And once again, because the 500 has no bearing on this particular route, we still have our 300 cars per hour. Now, down the bottom, this is where this is going to change slightly. Now, we notice that along this first road, we can travel. And then there's two different ways we can go. One way is we can go up to here and down to here. And the other way is to travel straight through down here. Now, we want to see what actually happens here. Now, since we've added this road, from A to D, I still have a flow of 500 cars per hour. Now, of these 500 cars that are going right now, 150 can pass along this path from D to E. So, we still, like we've done before, nothing really changes. We have 150 cars per hour. But of these 500 cars, 150 pass through here. But adding this new road, that now allows the remaining cars to take a different route. So we can actually get 350 cars going up to here. Okay, so I'm just going to pause for a moment for you to really think about this. We've added another road. So I still get the 150 cars, but those 150 cars can pass, leaving 350 to go along here. Now, those 350 cars, they're going to meet at this vertex C. Now, we have, let me do this in a different color. We have the 300 cars from before, from this route in yellow. They pass through A, B, C to E. But I also have the 350 cars that go along the vertices A, D, C, and E. So I have 350 going along here. The reason we can accommodate these extra cars, though, is because the road C to E has a higher weight of 800. So we have a total of 650 cars now going down this road CE, which means that we've actually increased our total flow through this system. So we have our 300 cars from the top one, A, B, C, E. We have our 150, but we have an extra 350 cars. So for part C2, our flow is the 300 plus the 150. That's what we had before. But plus the extra 350 that can flow through now that we've added this extra road. So that increases now our new maximum flow from 450 up to 800 cars per hour. So just adding one road that can accommodate has now basically almost doubled our flow throughout this entire system. This is where our network diagrams and understanding this flow for systems, for example, systems of water pipes or systems of roads, like we saw here, we can start to determine more effective ways to maximize flow through our system. And if you're designing roads, this is pretty beneficial for traffic, right? You don't want people complaining, sitting in traffic because the flow of cars is small. We want to maximize this where we can. So this is an application of the stuff we are doing here. But that brings us to the end of the video. Thank you so much for watching, and I'll see you next time.